So today we're going to start chapter 2, which deals with atomic structure. We're going to begin by looking at our modern idea of what the structure of an atom is. Then we're going to go back in time, a couple thousand years actually, and kind of work our way forward and talk about some of the scientists whose ideas got us to where we are today. So let's start off by talking about the three basic types of particles that build atoms. So first we have the proton, then the neutron, and the electron. And we can actually go a little further and further divide the proton and the neutron, but that's a higher level topic and you can deal with that in a college level physics class if you choose to go that route. So let's look at the abbreviations for these three particles. We abbreviate a proton as P plus, a neutron as N0, and an electron as E minus. So based on those abbreviations, you could probably guess a proton has a positive charge, a neutron is neutral, it has no charge, then an electron has a negative charge. Okay. You're probably already aware of this, but just be sure and don't get confused. Some people like to correlate neutron and negative because they sound a lot alike, but neutron corresponds to neutral. So the masses of these particles are extremely small. So the mass of a proton is around 1.67 times 10 to the negative 27 kilograms. Then the mass of a neutron is approximately the same. So those numbers are kind of difficult to think about because they're so small. So we have a different unit rather than kilograms that we use to measure mass, and that unit is AMU. So AMU just stands for atomic mass units. So one atomic mass unit is about the mass of one proton or one neutron. So we can say the mass of one proton is 1 AMU. The mass of one neutron is 1 AMU. So we'll refer to the mass of protons and neutrons as being 1 rather than 1.67 times 10 to the negative 27. So the mass of an electron is so small that we often don't even consider it. The mass of an electron is around 1 over 1,840 AMU. So that corresponds to around 0.00005 AMU. So yes, electrons have a mass, but it is so small relative to protons and neutrons. When we consider the mass of an atom, we for the most part just ignore the mass of each electron. Okay, so we know today that atoms have a dense nucleus, and that nucleus consists of protons and neutrons, so I'll just draw a generic atom here. So we can label that tightly packed nucleus, and that's where the vast majority of the mass of each atom is. And then we know, and again I'm going to draw a very simplified image here, we know that somewhere very far away from the nucleus we have electrons that orbit the nucleus. Okay? So I'm going to refrain here from drawing the rings that you're used to seeing. We're going to spend a whole chapter in a couple of weeks discussing electrons and where they actually reside in relation to the nucleus. But for now, just be aware that the electrons orbit the nucleus somewhere very far away from the nucleus. So we know that atoms are mostly empty space. And what I mean by that is we have a very tightly packed nucleus, and then we have a whole lot of empty space, then we have electrons orbiting around the nucleus. So that is the very simplified, most absolute basic idea of modern atomic structure. Again, we'll look more into that in a few minutes, and then we'll spend the next chapter dealing only with the electron. But for now, let's go back in time a little bit and talk about some of the scientists that got us where we are today. So first we want to look at, or talk about, Democritus and Aristotle. So Aristotle, you've definitely heard of. Democritus, you may or may not have heard of. They both were in the time period several hundred years BC. So we associate these men most commonly with ancient philosophy. So let's talk about what their ideas were with chemistry. So Democritus had the idea that if you take something like a stone and you split it in half, and then you take one of those halves and you split it in half again, and you continue with that process and you keep splitting each piece in half again over and over and over, eventually you're going to get some piece that is so small that it cannot be divided. So there is some tiny piece of matter that is indivisible. And he actually called this little piece of matter an atomos. So that is where we get the modern word atom from. So several hundred years BC, Democritus was actually very correct in that idea. But then Aristotle disagreed with him very adamantly. He had the idea that all matter was some combination of air, earth, water, and fire. And his ideas were a little complicated, and we won't talk about those much because they're obviously incorrect today. So they kind of had conflicting viewpoints, but Aristotle was more popular in the time, so Aristotle's idea actually was believed for several hundred years incorrectly. So then, in the early 1800s, there was an English school teacher named John Dalton. So John Dalton proposed what we call the atomic theory. Okay, so Dalton's theory had four main parts, or four main postulates. So here are the four postulates to Dalton's atomic theory. So we'll talk through them and then we'll talk about some of the issues with them. So first he said that all matter consists of atoms that cannot be created nor destroyed. The second postulate is that atoms cannot be changed from one element to another. The third postulate is that all atoms of an element are identical but are different from other elements. And the fourth postulate is compounds result from atoms combining in simple whole number ratios. So we know there are a few issues with this theory, particularly with nuclear decay and nuclear reactions. We now actually know that atoms can be changed from one element to another in very specific cases. We know that atoms can be destroyed, but we know that mass is typically conserved or converted to energy in one way or another. But if you look at number 4 down here, compounds result from atoms combining in whole number ratios, this was a big idea for this time period. He was one of the first people to make the distinction between atoms of an element being simply a single type of atom versus compounds resulting from different combinations of atoms. And then number 3, we'll learn in a few minutes that all atoms of an element aren't identical. They do have certain properties that are the same, but different isotopes cause different atoms of a specific element to be slightly different. So we see there are some issues with Dalton's theory, but to be in a time period when we weren't even sure, what atoms were made of, we didn't yet have a concept of protons, neutrons, and electrons, this was a big idea. So next we want to move forward almost 100 years. We want to look at the late 1800s, and we have J.J. Thomson we want to look at. So what J.J. Thomson did is he discovered the electron. And he did this using his cathode ray experiment. And we'll have a separate video really diving deep into that cathode ray experiment. But after he discovered the electron, he proposed what was known as the plum pudding model. So what the plum pudding model was, he proposed that there are these spheres of positive charge, and they have electrons just floating around in it. Okay? kind of like plums in plum pudding might be. So this was the prevailing theory of the time, and for several years this theory gained some traction and was widely believed. So then let's talk about Robert Millikan. So what Robert Millikan did is he quantified the charge of an electron. And so J.J. Thomson discovered that there is in fact an electron, and it does in fact have a negative charge, but Millikan was able to actually calculate the numerical charge of an electron, and he did this using his famous oil drop experiment. And so there will be another separate video really diving deep into the oil drop experiment and how it worked. So next we have Ernest Rutherford. And what Rutherford did was he used his famous gold foil experiment to prove, or rather discover, that atoms have a nucleus. Okay. We'll say he discovered the nucleus. So a quick side note here, the term nucleus that we use in chemistry is completely unrelated to the nucleus in biology. So in biology, the nucleus is the organelle that contains the genetic information. So in chemistry, it's completely unrelated. In chemistry, we know the nucleus is the tightly bound region where the protons and neutrons reside. But hopefully you know that. So please don't ever say that the nucleus is the brain of the atom. We won't go there. But he did also say that atoms are mostly empty space. Which is a big idea and a very important idea that we still know is true today. And then last we have James Chadwick. And he discovered the neutron. So now, through the cathode ray experiment, the oil drop experiment, the gold foil experiment, and a couple of other experiments we won't discuss in detail, we now have a basic idea of atomic structure. And then we have several other men, Niels Bohr, Erwin Schrödinger, several others that we'll discuss in the next chapter concerning electrons and their configuration and how they behave. But for now, we just want to focus on the basic structure of an atom. And these are the men that guide us to our current understanding today. And so we're going to stop this video here. And then we're going to, in the next video, take an in-depth look at the cathode ray, the oil drop, and the gold foil experiments.